You may have heard of the phrase mixing like oil and water to describe two things that don't mix well at all. I'm Tiffany, and in this experiment, we'll learn about what that phrase means, as well as what polar and non-polar substances and emulsifiers are. For this experiment, you will need 4 clear cups or containers, dish detergent, an egg, a teaspoon and a tablespoon, 2 bowls, 4 utensils to act as stir sticks, food coloring, vegetable oil, and white vinegar. In each of your 4 cups, add 2 tablespoons of oil and 2 tablespoons of vinegar. Add a drop of food coloring to each cup to help you better see the boundary between the oil and vinegar. Next, separate the egg yolk from the egg white. Do not consume the raw egg. You can mix the egg yolk so that it breaks. With your measuring spoon, add 2 teaspoons of the egg yolk into 1 cup and 2 teaspoons of egg white into another, and 1 teaspoon of detergent into the third. Nothing extra will be added to the last cup. Now, with a new stir stick for each mixture, vigorously whisk the liquids in each cup until they appear mixed. Over the next 5 minutes, observe what happens to each mixture. You'll have seen that the cup with only oil and vinegar separated back into their own layers very quickly, whereas in the cups with egg yolk, egg whites, or detergent, the oil mixes with the blue vinegar. Oil and vinegar alone do not stay mixed because oil is a non-polar substance while vinegar is a polar substance. What makes a substance polar or non-polar is the distribution of negatively charged particles known as electrons within the molecules of the substance. Vinegar is polar because its molecules have one end with slightly more electrons than the other, giving one side a slightly more negative charge and the other side a slightly more positive charge. This is similar to how a magnet has 2 ends. As a result, the positive ends are attracted to the negative ends of the other vinegar molecules. Oil is nonpolar because its molecules have a largely even distribution of electrons throughout the molecule, so the majority of the molecule is neither negatively nor positively charged. Polar substances don't mix with nonpolar substances because the polar molecules are more attracted to other polar molecules and not nonpolar molecules. The reason why the oil and vinegar were able to mix when we added in detergent and the egg yolk and white is because these 3 are emulsifiers, which is a substance that can help 2 immiscible liquids mix. Immiscible meaning that they do not mix. These emulsifiers contain amphipathic molecules, which means they have both a polar and nonpolar region. The general structure of a detergent molecule is that they have a polar head and a nonpolar tail. Similarly, the egg contains proteins that have polar and nonpolar domains. When you mix in an emulsifier, they help one of the liquids form small spheres which can be dispersed in the other liquid. This is because the emulsifier acts as a barrier between the liquids. In our case, the emulsifier's nonpolar regions face inside the sphere, interacting with the nonpolar oil, and the emulsifier's polar regions face outside, interacting with the polar vinegar. Therefore, this emulsifier allows oil droplets to be dispersed as small spheres throughout the vinegar. Emulsifiers are commonly used in food products, such as the use of egg yolks in mayonnaise, which is an emulsion of oil and vinegar, or milk, which is an emulsion of fat droplets in water. Another everyday example of emulsions is when you use detergents to pull away oil droplets from dirty dishes or clothes and rinse them away with water. In summary, we learned that 1. Nonpolar substances like oil have an even distribution of electrons in their molecules. 2. Polar substances like vinegar and water have different charges on the ends of the molecules, making them attracted to other polar molecules and substances. And 3. Emulsifiers have a polar and nonpolar region, allowing them to form small spheres of one liquid so that they can be dispersed throughout the other liquid. Thanks for watching. Try this experiment out at home and make sure to tag Pueblo Science with your results. Subscribe to our YouTube channel and follow us on Facebook, Instagram, and TikTok for more fun science content. Lastly, comment down below what you would like us to cover next.